6.1 maxima and minima. Okay, so when we look at maxima and minima, what we're talking about is we're talking about the vertex, okay? So like the minimum value or the maximum value. Okay, so as a recall, the vertex form of the quadratic relation is in this form, whereas h and k is the vertex. Okay, so as a little bit of a recall, a perfect square trinomial is an equation in one of the following two forms. So if we take a look at this and we expanded these like a plus b squared or a minus b squared, we would get these as the expansion. That's what we're going to focus on making the equation look like. If you take a look at that x minus h squared, that looks exactly like we have here, that factored form. Okay, so the whole purpose of today is we are going to take an equation and we're going to manipulate it so that it's the same equation and it's congruent. However, it's just going to look a little bit differently. Okay, so example 1, find the value of m that makes the following expressions perfect square trinomials. Okay, as a recall, if we root the first term, okay, so root of x squared is 1x, and we root the last term, so we have to figure that out. What we're going to get is if we multiply these 2 times 2, so if we have 2 times 1x times the root of m, this is going to equal 12. 12x. It's going to equal that middle term right there. Okay, so if we were to take this and we divide it by 2x, those go away. So we know root m is going to be equivalent to 6. So square both sides, m equals 36 in this case. Okay, and then the next one, same thing. If we root x squared, we get 1x. If we root m, well, we just get root m, okay? But we know that middle term is comprised of the root of the first term times the root of the last term times 2. So that expression is going to be equal to negative 4x. And we are going to divide by 2x. Those go away. So we have root m equals negative 2, and then we can square both sides. We get m equals 4 in this case. Okay, now we have instructions. They're a little long, and I'm going to go over them as we do the questions, but if we want to quickly read them. So what we need to do in order to get an expression from, like a quadratic expression from expanded form into vertex form, okay, what we have to do is we have to complete the square, and this allows us to find the vertex of a quadratic relation algebraically, okay, instead of graphing or guessing. Okay, so here are the steps. I'll quickly go through them. What we're going to do is we're going to write the quadratic relation in standard form, okay, first, and then what we're going to do is we're going to group these x terms and factor out any coefficient that the x squared term has. Okay, we don't actually factor out the x, just the coefficient of the x squared, because the x squared must begin with must have a coefficient of 1 to begin completing the square. Then we're going to complete the square by making the expression inside of the bracket a perfect square trinomial. Okay, so what we're essentially going to do is we're going to add a term and subtract the same term. By adding a number and then subtracting the same number, all we're doing is making this equation look a little bit differently. We're not actually changing the equation. Okay, I'm going to show you how to do this in a real example. So go ahead and follow those steps with me. From the steps, I just think without an actual example, it's difficult to understand. So what we're going to do is we're going to write each quadratic relation given in standard form, and we're going to write it in vertex form by completing the square. Okay, so the first step is to bracket the two x terms. Now the coefficient of this x squared term is 1, so we can actually skip that that step where we have to factor out the coefficient. And now what we do is we go to the side of our paper and we take this term here. We're going to eventually square it, so it doesn't actually matter if you do plus 12 or negative 12. Okay, so we're going to take 12 on the side of our paper, and how we complete the square is we divide this by 2 and then we square it. So we actually get 6 squared, which is 36. Okay, we take that number and we sub it into this bracket. So we have x squared minus 12x. Those two things come down. Now we take this and we sub it into the bracket. Plus 36 minus 36. Okay, we close the bracket and then minus 15. Okay, if you actually take a look here, don't simplify this. The whole point of completing the square is so that we make this look a little bit differently. Okay, so I get that plus 36 minus 36 is actually adding 0, but again, it's just to make it look differently. Okay, so we take this negative 36 out of the bracket, and then we have this trinomial, and it's actually a perfect square trinomial. That's the whole point of this. So negative 15, negative 36. This here, we should be able to factor. If you can't factor it, then your answer is most likely wrong. Okay, and when we factor this, it is a perfect square. It's x minus 6 squared. And then all we do is we go ahead and we go negative 15 minus 36. I get negative 51. And then that's it. Okay. If we wanted to state the vertex, it would be 6 comma negative 51. All right, let's go to the second one. Okay, so the exact same steps. The steps don't change. We want to group the first two terms we want to deal with. Okay, the coefficient of x squared is 1, so we can actually start the process. So we take this 8 and we go to the side of our paper and we divide it by 2 and then we square it. I get 16. So we come here and we insert in this bracket, so we write everything in the bracket as it is. X squared plus 8x. Now we add 16 and subtract 16. And then we keep going. Bracket, negative, or plus 5. Okay, so all we have to do now is take that 16 out, and we are left with a trinomial, x squared plus 8x plus 16, okay, which we can factor. It's a perfect square, plus 5 minus 16. So this perfect square trinomial factors to x plus 4 squared. And then when we have 5 minus 16, we get negative 11. And we're done. Okay? These two equations are absolutely equivalent. They're just looking a little bit different. Okay? And if you wanted to state the vertex, remember it's x plus 4, so we have negative 4, negative 11. Okay, so example 2, determine the optimal value. Whenever a question asks for the optimal value, what it's asking for is the vertex. Okay? And it's asking for like the y value of the vertex. And then that can either be a minimum or a maximum. Okay, minimum if it opens up. And then, oh, I did that backwards. This is maximum first. Maximum if it opens down. And then minimum if it opens up. Okay, by completing the square. Remember, if it says completing the square, that's exactly how you have to do it. So these two questions are a little bit different because this coefficient is not 1. So let's go ahead and factor out that 2. And although we could factor out an x, we don't. We only factor out the coefficient of the x squared term. So step 1, we got to group these. And then step 2, we're going to actually factor out that 2. So we have to divide each of these terms, just common factoring, by 2. Okay, so we get x squared, and then negative 8 divided by 2 is negative 4. Okay, and then we write the rest of the equation, plus 5. We're only pulling this 2 out of the first two terms. We can leave this one as it is. Okay, now we can start. We take that 4, we take it to the side of our paper, we divide it by 2, and then we square it, and we get 4 again. Okay, so let's rewrite this, and inside this bracket, we're going to write plus 4 minus 4. Okay? So, because we factored out this 2, what happens is when we bring this negative 4 outside of the bracket, we have to multiply it by that 2, since it's the negative 4 is in that bracket. So what we end up getting is 2 bracket x squared minus 4x plus 4. That's our trinomial. That's fine. The plus 5 stays. And now negative 4 times 2, we get negative 8. Okay? So we have to keep this factor. That's a vertical stretch by a factor of 2. So it's going to make our parabola a little bit skinnier and taller, quicker. Okay? And then we just factor, and this will always be a perfect square. And then 5 minus 8 is negative 3. So our vertex would be that 2 comma negative 3. Our optimal value is the y value, so negative 3. Okay, so the exact same thing. We are going to bracket the first 2 terms. So this one's a little bit different because we have a negative. So we're going to factor out the negative 3. Remember, don't factor out the x, just leave that. Okay, so those cancel out, we get x squared, and then that goes to a negative 2x, bracket plus 5. Okay, so again, side of your paper, take that 2, divide by 2, and then square it. So we get 1 squared, which is 1. So inside this bracket, we are going to write, I'm going to rewrite the entire bracket, but we're going to add 1, subtract 1. Okay, so this negative 1, we want to bring it out of the bracket, but because the in front of the bracket it's a negative 3, we're going to have to multiply by negative 3. So we're just going to rewrite this, negative 3x squared minus 2x plus 1. This is a perfect square trinomial. Okay, bracket plus 5, and now this negative 1 times negative 3, we get positive 3. Factor the perfect square trinomial and add these two. So our vertex is 1, 8. So our optimal value is 1. Okay, for example 3, we're given an equation. So it says for the equation, complete the square to express for example 3, we're given an equation here. Okay, and this is in standard form. So it asks us to complete the square to express the relation in vertex form. And then we're going to sketch the relation using the vertex and 2 other points on the curve. So we're going to use symmetry. Okay, so let's go ahead and rewrite this. Y equals negative, I'm not going to write the negative 1, I'm just going to write negative x squared plus 6x minus 11. Okay, so for this, we are still going to group the first 2 terms. And the coefficient of x squared is not 1, so we have to actually divide out that negative 1. Okay, so we get y equals negative 1 in front of the bracket x squared minus 6x, and then minus 11. So let's go ahead and take that 6 to the side of our paper, divide by 2, which gives us 3, and then square it, which gives us 9. Put a square there if you want. So inside of this bracket, we're going to go ahead and do x squared minus 6x, okay? So everything up until now, we rewrote the same, and now we're going to add 9 and subtract 9. And when we bring out that negative 9 out of the bracket, we're going to multiply by negative 1, so it's actually going to be positive 9, and we're going to add it, okay? So we just rewrite, so we have our perfect square trinomial, and then minus 11 plus 9. And now what we do is we factor our perfect square trinomial, and then minus 11 plus 9, I get plus 2. So our vertex here is positive 3 plus 2. So 3 and then 2. Okay, if we want to use symmetry, well, we know that we can go out to the right 2 and out to the left 2, and we can sub in the point for 1 and 5. So we can do this in either our new equation here or our equation up here, it doesn't matter. So if we were to go y equals negative, let's go 1 squared plus 6 times 1 minus 11. I get negative 1 plus 6 minus 11. So it's negative 12 plus 6. I get negative 6. Okay, because of symmetry, if you go ahead and sub in 5, you will also get negative 6. Okay, and you want to go ahead and minus x squared plus 6x minus 11. Label that curve. Okay, last one, same type of question. For this equation, and we can tell that this is a quadratic equation. We have an x squared here, and this is in standard form. We're going to complete the square to express the relation in vertex form, and then we're going to go ahead and graph it with 2 other points using symmetry. Okay, so y equals 3x squared plus 12x plus 10. Okay, so first step, bracket the 2 first terms. We have to pull that 3 out of there so that the coefficient of x squared is 1. So x squared plus 4x. Okay, take that x term to the side of your paper, divide it by 2, and then square it. So we get 4 again. So we get x squared plus 4x plus 4 minus 4, okay, and then plus 10. So all we did is we went into the bracket and we added 0, right? And our 0 looked like a plus 4 minus 4. So now we pull out this negative 4, but we have to multiply by 3. So we get 3, and then our perfect square trinomial, x squared plus 4x plus 4. And then negative 4 times 3, negative 12. So all we have to do now is factor this perfect square trinomial. I get x plus 2 squared. And then 10 minus 12, I get negative 2. Our vertex in this case is negative 2, negative 2, which is here. So if we're going to go ahead and graph 2 points to the right, we'd graph at 0. Oh, I shouldn't put a point there. We would graph at 0 and we'd graph at negative 4. Because these are symmetric, we only really have to plug in one of these. So let's go ahead and plug in 0. Y equals 3, 0 squared plus 12, 0 plus 10. 0, 0, we get 10. That means negative 4 also lays at 10 because of symmetry. Remember, this is the axis of symmetry. And here is our parabola. Y equals 3x squared plus 12x plus 10.